Hello, welcome to Topper Machine. I'm Josh Topper. So today we have yet again another very interesting job. This is a split shaft coupling for a old obsolete skid steer, and this one has been repaired at one point by somebody else, and they did a very terrible job, which led to more failures within the skid steer. So here is the coupling, and generally I would just recommend the customer orders one off the shelf. But this one's a little longer than normal. So you look, this is actually the good end, and you can see it's all wobbled out here. And we flip it around, and you can see what I'm working with. Now, somebody at some point had a problem with this thing before the current owner of the machine got it, and what they did was a terrible repair. They welded it up, but didn't do any finish machining. So what it actually wound up doing, it was off center and it did this to the shaft. Now that should be straight. So what we're going to do is make them a new one, and we're going to make it a little different than this because this was a casting that was machined. We're going to make it out of a piece of round stock and just make it work for the application. So we're going to start over here at the lathe with this piece of 2 3/4 inch round. I'll leave it stick out of the chuck a ways. I'm going to face it, center drill it, and then I'll do the outside work to it first, and then we'll drill it for the 1 1/4 shaft. I'm going to turn this down from 2 3/4 to 2 5/8. I'll do it in 2 passes. $22 thou to go. Now that last pass came off as one long fine string, and you got to be super careful about that. If you noticed, I never got in close, and I used this hook and never put my hand through the loop. Always grab it that way and just pull it and stay way back from the job. Now we'll do the step I want to put in the middle to offset that, and then we'll start boring it. Okay, so now I'm going to just touch it off on my running surface here, away from the end. Zero my readout. I'll go over to the end. I'll zero there. And I just want to take an 1/8 inch radius on the end. Just clean that up, make it look nice. Now I'll come in on the other end and do that same cut. And I already calculated out all my lengths, so I know where I need to be. I'm coming in pretty wide. I had to slow her down. I'm going to have to make this a couple of passes just to make it work out. But we'll get there. Alright, so I slowed it down to 355 RPM, and I'm going to take it in and just run a cut. I'm going to start here, end here. Well, I'll make a mark, and then I'll cut this way like I normally do. But I'm going to go in 250 thousandths, or I'm going to go 220 to start with. That'll get me my start mark. I'm just going to take it in 100 on this end, so I have a good mark, and then I'll come down here to my other, where I want to start down here, and do the same, and then we'll feed that 100s out. Now that's 200 thousandths deep right there. And I'll take another 20 pass, and then we'll measure it and see where we're at. See if we can't smooth that out a little bit. .403. And I want to go to 2.375, so we're going to take another 28 thousandths. Yeah, that looks real nice. I'll go ahead and just hit the sharp edges with the file, and then we'll get set up with the drill and bore that out. So for drilling this, we're going to just use the spade drill with a 1.25 inch insert, and this is a brand new insert, so this thing will cut beautifully. And what I found with these spade drills is they cut so close to accurate as far as the diameter that we won't need to bore it or ream it or nothing. So we'll just run this, and then once we split the part apart and clamp it, it'll be perfect. Shouldn't have any issues, so let's get this going. Alright, so I'm going to run 125 RPM to start with, and that'll just give me a little stability. And then once we get in a little ways, I'll crank up the speed. Alright, I just cranked it up to 250 RPM, now we'll plow through this. Alright, now we part it off. And in case anybody's wondering, just for fun, I threw the bore gauge in there. And 1.2505. So 5/10 over 1.25 inches, which is absolutely perfect. Once this is all done, that'll work out well. And I would generally run this significantly faster, but because I got coolant and the camera right there, I'm trying to keep the mess down. Well, there it is, all turned out. Now we got some milling to do. All right, so I'm over here in the Bridgeport. I got it set flat down in the bottom of my vise. I need to mill flat on this side, and we'll flip it over and mill flat on the other side. And so I'm just gonna bring the cutter over, touch it off, and then I gotta take 187 thousandths off. So we'll touch it off, zero the knee, and then we'll probably take 100 to start with. Then I'm going to take the 87. we just flip it over and that should be 180 degrees apart. And we'll double check by, to make sure our height is right, by just touching off again, and we should be zeroed though, right now. Yep, we are still perfect, just touched. So we'll take 100. And now 87 on our back cut. I got it set up in the vise. I'll just go ahead and find my edge, find my centers, and get everything ready to drill. Now that I got the cross holes drilled through, we're going to run a reamer through and true them holes up. Next step here is to counter bore in a flat for the head of the socket head cap screw I'm going to use, and then we'll drill through and tap the whole thing in the 4 locations. Now we'll drill through with our tap drill. I'm going to tap it, and I'm not going to go all the way. I will just get enough to get a good starter, and then I'll finish hand tap it because I don't have a lot of room here to get all the way through. So with it in the spindle, it's almost impossible to get all the way through this one. And now I'll just use a reduced shank hand tap to finish it out. All right, they're all done. Well, that's as far as I can go until UPS gets here tomorrow with the slitting saw to split this. So, let's get started on the shaft. All right, so I got my chunk of shaft. I'm just gonna get it in the lathe here. It'll face off the end. We'll cut the step that's on this end first and do the drill and tap on this end, and then we'll flip it around and face off the length and be ready to go. All right, let's see where we're at. 23 thou to go. Ooh. Yep, just a little polish with the emery cloth and we'll be perfect. It's very close to where it needs to be. Okay, now I'm going to run this tap in at 63 RPM, and the reason I use a drill chuck is because that can actually slip. So if it binds up, I'm more likely to slip the tap in the chuck than I am to snap it off. Yeah, perfect. Okay, I'll flip it around. I'll do a nice, a light face cut. Then I pull it out, measure it, and then cut it to final length. And 40 thousandths to take off. Here we go. Okay, I'm just going to walk you guys through the setup here real quick. This is the woodruff cutter that I need for this. And yes, I am going to bring the spindle down just to give myself a little more working clearance. And I'm just going to touch it. And then I bring it down half of the cutter, which is a 1/4 inch cutter, so bring it down 125. And then that's 1 1/8" shaft on the end there, so we go another 563 once I zero my knee here. So 1, 2, 3, 4, 5, 63. So that should be center of the shaft right now. Next we'll bring it over, bring it close, and I'm actually going to run this pretty slow, but I'm going to touch it off. And find the end of the shaft. And there it is. So I'll go in half of the cutter distance, because I'm actually going to use this as my edge finder to set my zeros. And then I go 1/2 inch, and that's where we start cutting our key. All right, now I've sped it up a little bit because I want to know, or I don't know how good this cutter is. So I sped it up a little bit because this is an old cutter. It's not the greatest. So we're just going to take it real easy, plenty of oil. And zero my readout, and in we go. Now usually I don't see a lot of Woodruff keys, actually hardly ever. I got a whole drawer full of cutters, and I got them used at an estate sale, and this is actually the second time I've used them in 4 years. So, I mean, I'm glad I got them so I don't have to order, but I don't see a lot of Woodruff keys anymore. 15 years ago when I was doing this for somebody else, I saw quite a few. So, times have changed. And we're almost there. And we're there. There it is. Okay, so here's our old shaft. And now we need to drill the cross hole down on this end. But considering how badly worn that hole is, it's kind of a guessing game. We'll get it as close as we can. I did some measuring and some playing around, and you kind of taking averages and hope for the best. And I came up with 8062 for the whole location. So we'll move the table over there, and then we'll center drill this, and then drill it and ream it also, so that we have a nice tight bolt hole. And now we ream it. Oh, here's the old shaft, all wobbled out and destroyed. And here is our new shaft. With a nice tight hole, a nice new keyway, all ready to go. Now we just wait for UPS to get here tomorrow and we can finish up this coupling. There it is, a 45 thousandths slitting saw. Hopefully I've got enough travel to get through it, and if I don't, I'll just finish that off with the bandsaw and hand file it. But so this cutter isn't going to be big enough, and this is the biggest one that McMaster-Carr had in this thickness of 045. So what I'm going to do is just kind of touch it off on a parallel. And that will get us right where I need to be. I'm close enough. And then I turn it up, split the difference of the cutter height, and then I go in the height, half the height of the part here. So I'm all set up where I want to be. I'm going to run the Cool Mist coolant spraying system, the portable one here that I got from KBC Tools. I'm going to use that instead of oil like I used to do, and I'm going to see how that handles it. And we're going to see if I can get all the way through. So let's get cutting. Well, I wasn't able to get all the way through, which is disappointing, but this was the biggest cutter that McMaster-Carr had that was 45 thousandths. So that's kind of the problem. I was limited to what was available, so we'll just have to finish that with the bandsaw. Not a big deal. Now we'll flip it around and do the other side. So we came very close to getting through, and we probably are almost through right in here because I did crank it in as we got there. I saw some wobble in my tool. I'm going to investigate that one further at another date, but I might have to replace that whole arbor because, I mean, the cutter fit on there tight. It might just have a bend to it, or it could be a wobble. But it's very old, so I'll look into that one. So. Well, she separated nicely. I'm just going to take it over to the belt sander and just give it a quick hit on the face to smooth it out. And then we'll take it over to the drill, bore out these threads on this end, and then we're all done. And this job is ready to go back to the customer. Well, I hope you enjoyed the video and how I did this split coupling and that new shaft for this obsolete skid steer. And unfortunately, let this be a lesson to everyone. When you buy used equipment, look it over very thoroughly and do a little research beforehand and make sure parts are even available. Unfortunately, this guy was several thousands of dollars of parts into it, and this was the last piece he really needed, and it wasn't available. You know, it's an unfortunate thing in the world we live in that parts are just not readily available anymore, and some things just are not worth saving. So kind of take that into consideration when you buy stuff. I hope you enjoyed the video. Stay tuned, there's more cool stuff coming. Until next time, get out in your shop and get it done right the first time.